Hi and welcome everyone to the Star Wars edition of AI 42. I want to start by saying hi to my amazing team members, Håkan and Gosha, and our speaker today, Pete. Hello everyone, how are you?
Oh, don't all speak at once. Yeah, good. Thank you. We were all being polite and waiting for each other.
You don't need to wait. All right, so it's so good that we are here together today again. I'm very happy that so many of you are joining us. Also, I will start by telling a few words about our speaker. Then Håkan and Gosha shares a few thoughts about AI 42, and then we'll let Pete to take the stage away. Is that all right? So Pete is a senior solutions architect at Octopus Deploy. He is the owner of PJG Creations and Microsoft Certified Trainer and Azure MVP, Pluralsight author, experienced public speaker, and meetup organizer. Wow, Pete, I have so many questions. For example, what does your role involve at Octopus Deploy?
Yeah, you're right. People read that stuff out and they just have to stop because there's too many words. I like to keep myself busy. So I'm recently joined Octopus Deploy. That was about 3 months ago. I think I've been there 3 months. And my role is in community, really. So I'm trying to help people to understand how to use Octopus better and how to integrate their own processes with Octopus, as well as perhaps the tools that they're using or would like to use with Octopus as well. And as well as going out into the community and meeting people and getting feedback that way. So yeah, it's a really varied role. It takes me all over the place.
That sounds really interesting. And you also wrote in your intro that you're experienced public speaker and organizer. Like, what topics do you usually present at conferences and meetups?
Yeah, I mean, I've run my own company for 12 years, mainly doing IoT. So, of course, IoT is close to my heart, and that's most of my talks will be about IoT, to be fair. But now, having joined Octopus, I'm picking up more and more of the DevOps side of things. So I've got a few conferences coming up where I'll be doing some DevOps, but I'll be over at NDC Melbourne talking about a Raspberry Pi robot arm as well. So yeah, I definitely won't be losing the IoT stuff because that's good fun as well. So hopefully I'll find some time to combine the two.
That sounds really interesting. And we also heard that you are helping in creating a certificate as well. Could you tell a few words about that?
Yeah, so way back in the day, sort of, I think 2019, I was invited to help create the AZ220 certification, Microsoft Developer Certification. And that was a really interesting process. And so I'm still involved to today in refreshing that exam and keeping it up to date, creating new questions that are relevant and knocking off ones that aren't. And I also helped create the Pluralsight content around teaching people how to pass that exam. So yeah, reasonably embedded into that system there.
That sounds really interesting as well. I think we will talk a little more before you start the session, but let me hand it over to Gosha and Håkan to tell a few words about AI 42.
Yes, so let us talk a little bit here about the motivation here for starting AI 42. So the motivation comes from the recognition that there is really no good starting material for getting into machine learning and AI. So here, AI 42, we are a strong team consisting of 3 Microsoft AI MVPs that strive to provide you with a valuable series of lectures that will help you to jumpstart your career in data science and artificial intelligence. And we aim to provide you with the necessary know-how so that it will help you to land your dream job as long as it's related to data science or machine learning. And this concept is quite simple. It involves professionals from all around the globe that will explain you the underlying mathematics, the statistics, probability calculations, data science, and also machine learning techniques. And that may sound like a lot, but don't worry, because we will guide you through it all. All you have to do is just to follow our channel and enjoy the content every second week. So it will be filled with real life cases and also expert experience. And we know that this is a lot because we have all started from scratch, but we're very happy to help you to build it up from there. And you can always stop and rewind the videos or ask for clarification in the comment section. And we hope to assist you on this wonderful journey and have you as a speaker one day. We believe that by creating cross collaborations with other organizations, we can give the best opportunities to broaden your network in the AI and data science communities. And with the combination of our offered services, we will be able to support less fortunate people and organizations that are not that recognized yet, even though they deserve it.
And our organization is sponsored by Microsoft and MICE, and we are humbled by all the support we get from our contributors as well. And thank you for Event Bongor for all the beautiful graphic content, and Mina and Marie for the cool intro music before our event. We are in close collaboration also with C# Corner and Global AI Community, so our lectures are going to be there on their YouTube channel as well as in our social media. Nicolette Tor creates and reviews all our text content that we use on our website and during our sessions. You can follow us on Facebook, Instagram, and Twitter, and to become a part of our growing community. And we are sharing the knowledge and fun there. You'll find every information that will bring you to an advanced level in the field of AI and data science. You can watch our record session on our YouTube channel and find our upcoming session on our meetup page.
And then we also have our code of conduct. So the code of conduct will outline the expectations for participation in our community, as well as the steps for reporting unacceptable behavior. And we are committed to providing a welcoming and inspiring community for everyone. So be friendly and be patient, be welcoming, and then also be respectful with each other. And you can find our code of conduct here on this link here. So with that said, let us go back here to the studio.
Hi, welcome back everyone. I'm so happy to be back with you. All the four of us is here to hear about what are we going to talk about today. So Pete, what are you going to cover?
Yeah, what was interesting is that my Percept was busy listening in the background there and decided to trigger. I thought, I'll just go and have a look at what it's doing. And it was listening to almost all of that conversation and was like, oh, how am I going to stop that? So I had to mute you all and let it time out and then refresh pages. So that's probably going to be a theme of this particular talk. So I'm going to be talking today about how you can, and along a journey, control your home using the Azure Percept. So yeah, it's going to be quite an interesting talk. It's demo heavy, and I've got lots and lots of virtual desktops to go through and lots that can go wrong. So we're going to be saying prayers to, I don't know, Boba Fett or something like that to make sure that my demos work.
That sounds really interesting. And I think I will let you take the stage away. And I wish you the best of luck and may the force be with you.
Very. And so, yeah, thank you for coming along to this talk. I'm going to be talking about the Azure Percept and how we can use that, as I say, to automate your home. So first, a little bit about me. We've talked about this briefly, so I won't go into a great deal of detail, but I am a senior solutions architect at Octopus Deploy. And I'm also a Microsoft certified trainer and an Azure MVP and a Pluralsight author. And I've been doing this for I don't know, well over 20 years now. And so, yeah, IoT pretty close to my heart now. I'm also a code club organizer, a STEM ambassador, and I've got 2 small children at home, 2 young girls. And so making sure that we can democratize this information is really close to my heart. It's something that I strive to do And I'm looking forward to when schools are fully reopened, so that they can run code clubs again. Because certainly the ones in our area are still a little bit shut down for that, sadly. So yeah, that's about me. So diving straight in, what is the Azure Percept? Well, this is Microsoft's venture into AI at the edge. And it's underpinned by some hardware. So at the center of all of this is the carrier board. And that's the brains of the operation. This is what's going to link everything together and do the processing. So onwards from that, we then plug in a vision board, and that allows us to be able to do vision processing at the edge. And then the period part of this talk is the audio module, and this is actually an optional module in the Percept bundle. But this is the part that's going to recognize voice and be able to then translate that back out into an audio format. So yeah, it's pretty much just those and a power supply, but I'm not going to put that on the screen. Some specs. There's no need to go into too much detail about this, but what it's trying to do is give you enough power to be able to do AI processing down here at the edge and then control all of those components. So it's a reasonably powerful IMX8M processor. And it's got TPM built on board as well, which helps us with our security, as well as Wi-Fi and Bluetooth and things like that. It's actually running Microsoft's own distribution of Linux, CBR Mariner. So yeah, just a little interesting piece to be aware of, that is. And then we're going to be running IoT Edge on this device, and then Percept Studio is going to underpin our cloud services as well. Moving on, we've got the vision module. I'm going to do a bit about vision in this talk, but not a huge amount because it's sort of tangential to what we're talking about. But this is an 8 megapixel camera capable of capturing at 30 frames a second, and it's got a nice wide 120 degree field of view. And then that's hooking into Azure Custom Vision, which is gives you another no-code solution to how this is working. And then the part that we'll be using mostly today will be the audio module. Again, this is an optional module that you add to the Percept bundle if you want to do the audio processing side of things. It's got 4 microphones in there and a 3.5mm socket to plug some speakers into, which is what I've got plugged in here, which you'll see shortly. And then that's going to use speech services and Azure Speech Studio. And again, it's no code. So to get a lot of this working, you're just going to be configuring stuff in the cloud on the web. So pretty straightforward overall, really. So moving on, these hardware components are themselves underpinned by some software. On that carrier board, we're using IoT Hub and IoT Edge. So this allows you to be able to have that edge processing capability and then communicate up to Azure through the edge gateway paradigm of the IoT Hub. And of course, this is a highly available service, allowing us to be able to connect millions of devices together without the need for a busy tone at any point. On the speech side of things, we've got speech services, including Lewis and things like that. So that's language understanding intelligence service and Speech Studio. So that's going to be doing our no-code speech projects. And then for the vision, we're using custom vision, which I'll dive into and show you these bits as we go. So that's enough of those bits of slides, because let's be honest, you're here for the demos. So what I've got is many desktops set up. So if I flick actually to this page just here, that was a spoiler you saw there. This is the set of kit, and this is live. Ooh, hello. So we've got the carrier board just here, and then we've got the vision module, and then the audio module with some speakers plugged into it, and then Chewbacca, just making sure that we're doing the right things. And if we're not, then he's going to get angry and start firing arrows at me. He won't, trust me. So as a little preface, I actually wanted to add way more Star Wars into this talk, being it is May the 4th. But sadly, some of the libraries that I wanted to use to get a particular project to work have recently been updated and broken. So yeah, so it made me a bit sad, but don't worry, there's bound to be some puns as we go along. So those are the various different bits. And as I mentioned, we're going to be spending some time in something called Azure Percept Studio. So when you get your Percept, you'll come along into here, and this is where you're going to get started. What's great is there's a bunch of demos and tutorials, and you can try out things like some sample vision modules here if you wanted to, or create your own vision prototype, or there's some sample applications for people counting and vision on the edge and things like that. So that works quite nicely to be able to do that. But what you can do is you can create a custom vision project to be able to recognize objects, and I've done just that. So hopefully this will actually still be working. So there we are. There's my hand, and you can sort of see that working there. So what I've done is built a really simple and obvious sort of demo here. And don't worry, I've got a hammer, but it's okay because the Azure Percept knows it's a hammer look. So it's recognizing that hammer in real time, which is great. And it can also tell the difference between that and perhaps a screwdriver. So there's a screwdriver look. So I've trained it to recognize those particular objects, which actually this came from a demo that I gave way back in the day. And I think Gosha was there. We co-organized an event around AI. And it was from an MI42 sort of it was a project that they put a bunch of images that were stuff out of context, like the end of a hammer chopped off and the handle of a screwdriver chopped off, just to prove that there's a lot of bias when you're training stuff like this. But we can see this. So if I go to my custom vision project, so this is called Percept Vision 1, and what you have is a whole heap of training images. And if I go into one of the training images, you can see I've trained a screwdriver there. So it recognizes that. And I've tried to be reasonably good about it. So if not all of the screwdrivers there, like this one perhaps, look, so I'm only labeling the screwdriver part as the screwdriver, just to kind of try and give it a bit more context, because it could easily think that if I'm tagging my hand in there, that my hand is part of the screwdriver, which we know it's not. So when you've done that, then you're able to train the whole AI package, then the model, and then deploy that down onto the device. You can get more information about it in here. I've actually gone through 6 iterations of this training. Actually, I trained it on that iteration 4 and 5 and made the whole thing worse. So I had to do some more training. It doesn't always work. Certainly, you can overtrain your model as well on certain things. So just bear that in mind. You can actually see some of this if you go to the vision side of things. We can see there's the Percept Vision 1. This is an older project on image classification. But you've got this Percept Vision 1, and clicking into that actually gives us a bit more information about that. So there's the project and some information about that particular iteration and onwards from that. So yeah, again, that's pretty straightforward. It's not particularly difficult. And once you've trained that, you just go to evaluate and deploy, and then you can deploy it down onto your Percept. So in my case, that would be this Percept Hub 1, and then you just deploy it. And it takes, I don't know, maybe 3-4 minutes to deploy, because there's a fair amount in that model. And then once it's on there, then you go back to your web stream and you can test it out. So yeah, it works quite nicely. And I mean, I wanted to give you an idea of what that vision module did and how you could use that. And there's way more interesting things you can do with that. I know my friend Cliff Aegis has created something that recognizes all of the parts of an airplane he's going to build. And yeah, he's a pilot and he's going to build an actual airplane. And if you imagine, there's quite a lot of parts that you don't know quite what they look like, and you pick them up and you've not got the manual. And so he can hold it in front of his Percept and it'll actually tell him what that part is, which I thought was quite cool. I also saw a demo that came out of the Microsoft Hackathon, where they had a Percept camera pointing at the tray table in a operating theatre, and it would have all of the instruments that the doctors and nurses were using there, and it would recognise if any of them were missing and which ones were actually there. So that was quite a good real world example of what you could do with this. So I quite liked that. So moving on to the sound element of things. Again, if you go across to our Percept and we go back to the Percept Studio, and we go back to overview, in demos and tutorials, there's a few speech tutorials and demos, and one of them is this voice assistant. And so you can see there's just some idea of what Microsoft might think that some of the ideas you could use this for are. And obviously we're not limited to these ideas, but it gives you a way to be able to test it. And understand how this works under the hood. So we can see there's hospitality, healthcare, inventory, and automotive. as an example there. I've actually deployed that hospitality demo over here. And you can see why I'm using this one, because actually what I'm going to be demonstrating here is a demo, if you will, of home automation using the Percept. And this does actually work in theory. So let's see what happens. Computer, turn the television on.
Okay, turning the TV on.
Let me see the television's on. Computer, turn the lights on.
Sorry,
Oop.
I didn't quite catch that.
Computer, turn the lights on.
Okay, turning all the lights on.
And it's contextual as well, so it knows. So computer, turn the lights on.
All lights already on.
So it already knows that the lights are on, which, so we can feed back that sort of information. We can see we've got a thermostat there as well. So computer, set the thermostat to 68 degrees.
Set temperature to 68.
There we go. And we can just turn bits on as well. So computer, turn the bathroom lights off.
Okay, turning off the bathroom light.
So yeah, I mean that there gives us an idea of how you'd use the sound elements of this. And obviously, I'm talking and then expecting it to be able to pick me up straight away without leaving enough of a gap. So really, you can blame me for that. But you can see that it's quite reactive, and it gives you a good idea about how you could go about building this sort of a system up from scratch. Under the hood, this is using a bunch of speech services. So we're able to convert our spoken word into text, and then we can use Lewis to be able to then understand the intent behind our words there, and then translate that into an action afterwards. And then we feed back from that action a sentence, if you will, a contextual sentence to say what's actually happened. And then the speech module there will then convert that from text back into speech. So end to end, it's using a fair amount of different services here to hook that all back up together again. So seems to work quite well. I quite like it. But that kind of just gives you a flavor and doesn't really give us exactly what we want. So if I switch back to my slides now, and we go across. Home automation is what we really want to talk about. So what I've set up on my desk here is a system that it sort of jumps through quite a few hoops. And so I want to show you this, and then I'll show you the demo afterwards. And we also got to hope the demo works. But that aside, I'm starting with the Percept Audio Module, and I'm going to be able to give that commands. And then that's going to use all those services in the web to be able to then convert the intent of what we want it to do, and out through those speech services to an Azure function. So you'll see there that once we've understood the command, we can then, using a web endpoint, call out to an Azure function to be able to do something. Sadly, there's no direct integration with that and an IoT Hub, which is the next on the steps there. But the Azure function, that gives us the control after that point. If you can get out to an Azure function, you can do pretty much anything you want. I am looking forward to the day where we get direct IoT Hub integration. I think that would be pretty powerful when we get that. So from the speech service the speech project out to the Azure function, I deliver what it is that I want it to do, the command. And then that goes out to an IoT Hub and then onto a Raspberry Pi. So really, I'm using the IoT Hub as a broker, if you will, a gateway for us to be able to communicate with the Pi. So I call into the IoT Hub and actually invoke a method on the Pi, which then, at that point, will connect to a mains relay and to a desk lamp to turn the desk lamp on. And obviously, you can see there's quite a few hops there. So we're fraught with danger, but it should be fine. Should all work. It's all good. So let's go see what that looks like, shall we? Just to give you an idea of what it is we're doing here, I've got the Speech Studio on the screen here. And what we have is we have the custom command, and I've just got one in this case. So turn the light on or off. And we have a bunch of example sentences. So in here, if I zoom in a bit, you'll be able to see a little bit better. You can see that I've spelt out the number of different ways we can actually turn a lamp or a light on and off. And yeah, we could go on and on and on at that point. But it needs to understand that you could say this in many different ways. And this is like any home assistant, if you will. So in our case, we've got turn the light, and then we've got some green text here. And that's actually a parameter that we can see on the left-hand side. You could have a turn light on command and a turn light off command, but that's a bit wasteful. So we can actually accept parameters in here. So if I go to the parameter, you can see that it's a type of a string, which makes sense. We could have a default value, but I mean, which are you going to default to, on or off? So we're not going to use that. And the values we can have for that are either on or off. So, pretty straightforward. And then at the end of that, we've got what's called a completion rule. And I've created one of those that's just called done. And that calls a web endpoint. And if I go into the web endpoints here, then we have a URL that it calls into, and I'm using post to be able to call into that. So it understands that command, and then it calls out to that web endpoint. Actually, if I go back to turn light on and off and back to done, if I click on this edit here, I'm just passing a state of that parameter that we had of on or off. And it's going to call into an endpoint called light control. And you'll see then when I show you the code that the Azure function is then initiating that process through the IoT Hub and down to the Raspberry Pi. So that gives you some idea of what that looks like. So let's see if we can get it to work, shall we? So the first thing I need to do, though, is I need to tell my device that it's going to be using that particular speech. I think, do I do it from here? Go to commands. There we are. You can actually see I can assign different keywords as well. But the one I want in this case is this Percept IoT Hub speech. And if I click assign, if I go back there, I'll need to assign it to my Percept and then click save. And if I'm fast enough, you see the LEDs on the sound module flick on and off. That's it assigned. So it should be down on our device now. So the code is actually running on my Pi. So I've SSH'd into my Pi, and this is all in .NET, and I'll show you the code for it shortly. But let's see if it works. So computer, turn the light on.
The light
good.
has been turned on.
So if I go back, and then should be able to see now that we are lit up over there in our shadow. So computer, turn the light off.
The light has been turned off.
I'm going to do this one more time and show you my hands just so you know I'm not cheating. There you are. Over here. There you are. Computer, turn the light on.
Add your fallback message here.
Oh, thank you. Computer, turn the light on.
The light has been turned on.
So yeah, that's that works. So I'm really happy with that. Actually, that's pretty impressive at that point. And so yeah, that's going through quite a few different hops. So if I come across here, then the first thing it's doing is going to the Azure function. So if you remember from the slides, that way there, you can see that it comes from Azure Speech Studio, and I showed you how that gets out through that web endpoint and then out to an Azure function. And this is the Azure function. So all this is an HTTP triggered Azure function. So I'm not doing anything particularly special. And in fact, most of the code that you'll see here, you get when you create a new HTTP triggered Azure function. But what I have done is I've added a couple of extra bits onto the bottom here. And mainly it's this Microsoft.azure.devices NuGet package. And that's allowing me to be able to then hook up to the IoT Hub. Scrolling down a little bit further, we have a connection string that I'm storing in my environment variables. So I pull that in here. And then there's a bunch of scaffolded stuff here that we've not needed to worry too much about. That you'll get automatically. And then I log out what that state was that I've passed in as part of the function. So I can grab that out from the data and then stick it out onto the console. And then I just say that my HTTP triggered function was executed successfully. And then I create a new service client. So just to give you a little bit of background, when you are trying to control devices that are connected to an IoT hub, you need to connect at what's called the service level permission. If you're a device, then you're going to be connecting at the device level permission. And the reason being is that we don't want devices to be able to control other devices. So the service level permission allows you to be able to control devices from that point. I then invoke this method down here, passing in that state. And there's not a huge amount to this. So I say I want to create a new cloud to device method. So the IoT hub is in the cloud and the device sits there waiting, and you'll see in the code, for this particular method to be invoked on it. And so I create one of those. I say timeout after 30 seconds because, you know, the device could be offline. And I set the payload to be pretty much exactly the same JSON that I'm passing in with the state. And that's either going to be on or off, if you remember. And then we wait for a response when we invoke that device control device. That's the name of my device there. And then that's the method invocation that we're creating above. And then we just write out to the console what's happened at that point. And we can actually see some of that in action if I go across to my Azure function. Then if I can go into one of these, this is an old one, but you can see that this was executing. If I zoom in a little bit further, be able to see that. We're executing that Percept IoT function. We've passed in a state of off. The state was off, and then we executed the Percept IoT function successfully. So that's just a bit of logging that we get coming out of that. So going across a bit further, we come out of the Azure function and then go through the IoT hub and down to our device. So all of this code is all .NET. .NET 5 in this case, actually, rather than .NET 6, just because I've not updated it. And here we're also using the Azure, but we're using the client side of things here for devices. And then I'm also pulling in this system.device.gpio NuGet package. So azure.devices.client is going to allow me to connect up to the IoT hub so that I can listen to that method invocation from the Azure function. And then system.device.gpio, that NuGet package allows us to be able to communicate with the pins that are sitting on the side of our Raspberry Pi. I've got another talk that goes into a bit more detail about how that all works, but GPIO is general purpose input output. And so that's a collection of pins that give us, you know, things to be able to turn LEDs off or read buttons, or control serial ports or pulse width modulation for robot arms and things like that. So that particular library is hugely important because we can't do anything else with it otherwise. So next, I create a device connection string, which I've not put in here. And then I set aside a pin number that I've got that relay connected to. And in this case, it's pin 32. It's worth understanding that relays work a bit backwards. So you don't send a pin high. You don't write a true value to a pin to turn a relay on. You have to send a low value, a false value to it. So you'll see in a bit that it seems a bit backwards, but that'll make some sense. Next up, we create this GPIO controller, which is coming from that device.gpio NuGet package. We're passing in a board numbering scheme of board. And it's worth knowing the difference between this because you can also have BCM. And BCM is referring to a chip on the Raspberry Pi that controls the GPIO. But if you go ahead and use that numbering scheme, then you have to convert from the BCM numbering scheme to the board numbering scheme in your head. Or use some form of a little board that you put on there like I've got. Just seems like a waste. Just stick to board. That's my tip of the day. Next up, we open that light pin up as an output because we're going to be controlling that relay. And then, as I mentioned earlier, we set that value to high because that turns the light off by default. I think that's, you know, the safest option. Next up, we create our device client. And this part here is the part that's going to connect us out to Azure, to the IoT hub. So we pass in our device connection string, and then we're using something called MQTT, which is just a queuing protocol that you can use to communicate with the IoT hub. Next up, then you can see here is the part that's waiting for that control light. And by the way, do ask your questions in the chat or wherever you need to. We're more than happy to answer those. I'll answer them as we go along or at the end. So yeah, don't be shy. So we've got that control light method that we're waiting for, and so I'm awaiting that there. And then if that's received, then I just say it's been received, and I spit out the payload as JSON. So that's our state and on or off, if you remember. And then I just convert that to an object. And then if the state is on, then I set the value of that light pin to low. So again, remember, it's backwards. Setting the relay to be low will turn the light on, and setting it to be high will turn the light off. So that makes some sense. Then I just say that this is the response message of OK. When you invoke a method from an IoT hub to a device, it expects a response. If you remember in the Azure function there, we had a timeout of 30 seconds, and that's part of it. So it's waiting for that response to happen. You can, of course, say that it's not OK, and it's still fine with that, but then you need to handle it. And then we just return that response message with a 200, which is the HTTP code for OK. And then I say I'm waiting for the command, and then I do nothing at all. I just sit there and wait, and that's all I'm doing in this particular code. And we could see that. So that's what it was doing there. So waiting for command, and then the IoT hub invoked the control light method, and the payload was that state of on, and then add fun item onwards and upwards from there. So I mean that gives you some good idea about how a lot of that is hanging together. And actually, I'm really sad. I did want to demonstrate a little board down here, and if you kind of put me back to full screen rather than sharing my desktop, then what I've got here is an ESP32 with some LEDs and a speaker attached to it. And my plan was to, at this point, switch across to this demo and invoke that method by turning on the light. And what it would have done is flash those LEDs and played the Star Wars theme tune. But unfortunately, because of how development works, I'm using something called the .NET Nano framework, which is fantastic. Jose Samoes and a load of other people, Lauren Ellerbach over at Microsoft, are involved in this open source project to bring .NET to microcontrollers. So these are teeny tiny little memory limited, CPU limited devices, and we're able to run .NET directly on these devices, which is hugely influential actually, because ordinarily you'd be in something like C or C++, which is historically very difficult to get used to. Certainly when it comes to memory, it can be very complicated. You can absolutely do a lot of this in C. There's nothing stopping you from doing that, but C# is a lot easier. But if we flick back to my screen share, I can actually show you some of the code that I would have run. Here's what you could have had. So here's some Star Wars code. So I've got almost exactly the same sorts of things. So I've got a GPIO controller, and I'm setting aside some pins, blue and red pins, and some variables. And all of these constants here are the notes that would have come out of my speaker. And then a bit further down, we set up our connection to the IoT hub. And then I set up a GPIO controller. And then I set up my pins. So I've got the blue and the red LEDs here, and I'm setting those both to be outputs. And then I just default them to be off to begin with. And then the ESP32 that I'm using down here has got Wi-Fi built in. So it's really cool. So we can connect that to the Wi-Fi and then hook up some handlers. And then we open the connection. This is the part that's broken at the moment, sadly, is when you open your connection, you get a socket error. And I set Jose off earlier fixing it. It's possible he's actually fixed it while I've been on this talk. But I'm nowhere near brave enough to try and test this out live on air, because anything can happen. But hopefully, my plan is that I'll finish off this and go and check, and hopefully have fixed it. And what I'll do is I'll record a little video of it, and then I'll tweet that out. So keep your eyes open on my Twitter there for that to happen. And you can see then we can do things with device twins if we want to. But a little bit further down, we've got a beep, and that's what's controlling our beep. And then we've got some music that happens down there, blinking LEDs, connecting to the Wi-Fi. And then at the bottom, we've got our control light, and this is the exact same type of routine that we had over on the Raspberry Pi. So I still get the payload and I spit that out into a debug line and deserialize it. And then I would have started the Imperial March at that point and started the LEDs blinking. But I'm very sad, shed a tear that that's not working. So all you can do is just, be happy that we've got Chewbacca in here. But yeah, that's how that would have worked. What's great about it, by the way, is that you can do all of this in Visual Studio. There's a fantastic extension for .NET Nano framework that allows you to actually debug this live on that ESP32. So if you're only just starting your journey, if you start looking at the ESP32, debugging these things is really difficult. But with the .NET Nano framework extension and using .NET Nano framework, once you've flashed the thing with the firmware to be able to do it, you can then actually debug it live, step through your code, set breakpoints, get variables out of values out of variables. It's super powerful, and I'm very sad that I can't actually demonstrate that to you. But at least you've been able to see how that's working, albeit not working under the hood. So if I go all the way back to my slides, that is the end of the demos. You saw how that all worked together in there with, if I go back a slide, with the Percept Audio going through Speech Studio, out through an Azure function to the IoT Hub and down to a Raspberry Pi. So quite a few hops. And to say one day I'd like to see that Azure function negated and just being able to go directly to an IoT Hub. That would be quite powerful, I think. There's some links here that I know they're going to get either tweeted out or put on the screen here, but I've got a blog post actually that you can go and check out. Over here, with everything you need to be able to get this all set up. So it talks about custom commands and that that looks familiar. Yeah, that particular diagram. Creating the Azure function and then using that in VS Code, and so step by step on everything. It's quite a long post, but don't be deterred. I've tried to make it as step by step and simple as possible. Was that Raspberry Pi pulling from IoT Hub or IoT Hub pushing to the Raspberry Pi? Yeah, essentially it's been pushed. There's a socket connection that's opened up and it just waits while it's connected for that command to be invoked. And so, yeah, your Azure function will call into the IoT Hub, and then the IoT Hub is then coordinating that communication down to the device at that point. So yeah, that I hope that answers that particular question. Sorry, you've disappeared off the screen. Not quite sure what your name was there, so apologies. So go and check that out. I think the link will be put up there for you to be able to see, but going the wrong way. But yeah, if you go to that bit.ly there, then that'll take you to that particular piece of code. The GitHub repo for everything I've showed you aside from the Star Wars stuff, because I didn't want to put that in there until it was working. You can find it that bit.ly there. So that'll be the Azure function and the Raspberry Pi code are both in there. So you can go and check that out. If you need some more information about the Azure Percept, then check that bit.ly out. And then onwards, you can look at speech services and custom vision there as well. So that's those bits. I'm also, we're on a break at the moment, which sounds very much like Friends, but it's not like Friends. Part of a Twitch channel called Azure Live, and I have a show on there along with Cliff Aegis and Maria Anastasia Mustaka, where we just do a weekly roundup of IoT news and get some interesting guests on to talk about IoT tech and stuff like that. So do go and check that out. You'll be able to find the Azure Live YouTube channel with our historic shows on there as well. So you can go and check that out. It was mentioned at the start, Eve mentioned it, that I helped create the AZ220 certification, and I've also helped create the Pluralsight content to help you pass that course. So if you're interested in taking your IoT knowledge to a level that perhaps get you a job, then this is definitely a place to start. That certification is pretty broad, let me tell you. So if you pass it, then you're in a good place. And that Pluralsight, that set of Pluralsight courses will definitely help you to do that. So you can see the Pluralsight link at the top. You can hit that up and go and check that out. There's a couple of things coming up that aren't IoT based. So today actually super busy for me because it's a webinar day at Octopus Deploy. and we give out this webinar 3 times during the day in 3 different time zones. So we've already done it twice for APAC and for the EU. But if you're around at 8 p.m. tonight, then the final session of the day will go live then, and you can come along and listen to how to do config as code with Octopus Deploy. So that's quite a powerful feature. If you're back on the .NET side, I also run Knots IoT, and I was mentioning .NET Nano framework there. Well, Lauren Ellerbach, Microsoft employee there, principal software engineer, he's involved with that project as well, and he's going to come along next Thursday to talk to us about the .NET Nano framework. So definitely go and check that out on Meetup. You'll be able to come along to that virtually and see what that's all about. And finally, myself and Chris Reddington, also from Microsoft, on the 18th of May, we'll be talking about how we can use GitHub Actions with Octopus Deploy. So lots of things coming up. If you need to contact me, then at Pete_codes is definitely the place to do that on Twitter. That's the easiest. You can email me, peter.gallagher@octopus.com. And if you want to check out all of my blogs, then petecodes.co.uk is the place to do that. Knots IoT, .NET Knots Dev Workshop. I'm also involved with a Loughborough-based networking group called Lati, the Agile Engineering podcast, which is DevOps and Agile Engineering. You can go along and check that out. And then the Azure Live Twitch channel. And the slides will be available at that bit.ly at some point in the next day or so once I upload them. So yeah, thank you so much for coming along to my talk. I hope it was interesting and gave you everything you wanted. And yeah, may the force be with you, as they say.
Thank you, Pete, for the great session. It was really cool. I love that how you were having a conversation with Chewbacca on the way.
yeah, that it doesn't say much these days, you know. He's a bit quiet. He needs to speak up a bit.
I was wondering, how can someone get started with all this cool stuff without any knowledge, basically? So, for example, I might have some stuff that I could use as an IoT edge device, but I am not sure, other than what you just shared, links where to start this.
Yeah, there's quite a few things. I mean, if you're talking about something like a Raspberry Pi, if you've got a Raspberry Pi, then if you go along to the Pete Codes website, then if you do like Raspberry Pi.net 5 or something like that, then Google will help you there. And so I show you how to install and use .NET 6 with the Raspberry Pi. This is quite easy these days, actually. I didn't go into any detail with it, but there's actually just one single command that I've created that'll get the .NET framework installed on your Raspberry Pi directly, and then you're off and running with .NET. And then under that, there's a whole heap of stuff that will just get you through. So simple circuitry to be able to read a button and flash an LED. And so some of this is in my Raspberry Pi Robot ARM talk, but there's a heap of different blog posts that you can go through there, and you can. It's all backwards compatible, which is a nice thing. So I started messing around with .NET on the Pi when it was 2.1, but when it was 3.1, then I made a bunch of articles on here that you can read, and so you can then move up to actually adding the I to IoT there as well. All the way through to remote deployment and debugging. So there's that. It's obviously self-promotion. That's where I'm going to start that. But there's a fantastic resource that the makers of Autodesk have created called Tinkercad. And I can't show you that because I'd have to log in. It's not a great problem. But what that does is that gives you a design surface that you can drag things like Arduinos and micro bits onto. And then you can play virtually in the browser with this IoT stuff and program it directly. It's super powerful, all free. You just need to register. And you can drag all of the components that you want to, and you can make things, drag things like motors and stuff on there and make things virtually move. And the great thing about that is that if you're doing Arduino stuff, you don't have to do it in C directly. You can drag programming blocks like Scratch. If you've ever used Scratch, you can just drag that on there. So for a beginner who will often get given something like an Arduino, to go and pick up C can be quite daunting. If you're not a developer, or even if you are, C can be quite daunting. So to be able to do it in that block-based paradigm, a bit like Logic Apps, if you will, is super powerful. I like that, and you can export it out of that environment and program it onto the real device, and it'll just work as well. So that's always my recommendation. Go and check that out. There's also Jim Bennett has created a fantastic series of IoT tutorials. I've not got the link for that, but if you go and search for Jim Bennett IoT classes, you'll find that on GitHub. That's really good. He's spent a lot of time on that and making it really good. So yeah, congrats to Jim for that one.
And congrats to you too. You have some amazing blog posts here. I was just checking it out in the meantime.
I also have a couple of questions here, Pete. So one of the questions is, because you were mentioning here the .NET Nano framework that you're using here on the Raspberry Pi, but is it a special version of the Raspberry Pi that is supported, and what other types of microcontrollers supports that type of framework?
That's it, yeah. So just to be clear, I'm running full .NET Core for ARM or .NET 5, in my case, actually .NET 6 on my Pi these days on there. So this is just the ARM distribution of the SDKs and everything on the Pi. But on the ESP32, this little device down here, that uses this Nano framework. And I guess kind of the clues in the name a little bit with Nano being so small. These devices, they can't handle full .NET. But there is another device called a Meadow F7 that Wilderness Labs have created, and that's fantastic as well. And I'd be remiss if I didn't mention that. And that uses this is a microcontroller with an ARM chip and an ESP32 on there, and that uses full fat .NET framework on there. So they've managed to squeeze that in there. So that's a remarkable project that they're working. Brian Kostinitz and his team are working on over there at Wilderness Labs. So it's worth checking that out. But yeah, specifically .NET Nano framework. This is an implementation of .NET that they're spending a lot of time making. But it's pretty much full C#. Pretty much anything you want to do is going to be included in that. And they just have sort of almost interfaces to the actual full .NET assemblies in there. So they've just worked around the memory limitations to make that work. Yeah, so go to the nanoframework.net website to find out a bit more about that.
Nice. And a second question is here, because you were also demonstrating that you were using the Azure IoT Hub. And can you say something about what is the cost associated with using that? For example, what are sort of the Azure costs?
Yeah, mega low. In fact, if you're just playing, there's a free tier, and that allows you something like 4,000 messages a day, which actually that sounds like a lot, but it's not a lot when you start doing the maths. But it's great for just getting you going, and that will cost you nothing. You can sign up for an Azure subscription, and you can get $200 free, I think it is these days, or the equivalent in pounds or euros, to be able to play. A lot of the services you'll get as part of that will also be free for 12 months, and then after that you convert to a regular pay as you go and pay. But even after that, I think it's for the standard tier, I think it's about 15 quid a month, and then that gets you for I think it's something like 4 million messages a day, and then you're off and running at that point. There's a basic tier as well. The basic tier cuts out things like cloud to device messaging, so no good me using basic tier for this one. But if all you want is to ingress into the cloud or egress out of your device to the cloud, then the basic tier can sometimes work, and that's half the price, which sort of makes sense. But yeah, super cheap, and when you're in the standard tier, millions of devices, you're really limited on the number of messages per day, and then you can step up. If you start going over that, then you're probably making money, so you can afford to pay for your IoT hubs then at that point.
And also, speaking here of messages, you got a message here from Ben Watt, who was asking a question here previously in our session.
Yeah, that's fantastic. Yeah, definitely do, Ben. Follow me on Twitter. I've reached the 5,000 follower limit on Twitter. I follow a lot of people. It seems.
Yeah, there is a limit. Okay.
Yeah, so I think you'll see it's either 5,000 or 5,001 I'm on at the moment. So I keep having to go through a list and unfollow people that aren't posting anything, and then I can follow other people. It's really annoying. What I need is that little blue tick, and then I can do what I want at that point. But yeah, absolutely do. I'd be keen to find out what it is you're doing, and if you've got a GitHub repo or blogs, then absolutely send them out. And if nothing else, I'd love to get you on Knots IoT if you'd be interested in speaking. So thank you, Ben. Really appreciate that.
And I have a final question here. You were also mentioning the AC 220 certification exam, and can I ask you, have you taken it yourself, and how was it?
I tried to take it, they won't let me because I created it. They automatically award you the exam result. It would be very unfair. However, what I have done is the refresh. That you do a refresh. I think to keep it updated, you have to go through this little refresh exam, and I did that. But I also wrote that refresh, so I think I got 99. I didn't actually get all of them right because actually some of them are quite tricky. And I didn't actually write all of those refresh questions. It was a group exercise, but I'd seen them all, of course. But yeah, actually, that exam is hard. And every time I have to create new questions, and that happens quarterly, I find it hard to write new questions because I've been involved in writing all of them so far. So that's hundreds and hundreds of questions, a lot of which aren't even in the exam anymore. But also, there's so much new stuff being added all the time to that whole Azure stack. And the IoT stack is broad. So you've got the IoT Hub, but it also touches Stream Analytics and the now defunct time series insights and machine learning and storage and permissions. And there's, it's not as bad as AZ400, though, which is the DevOps exam. Oh, that even asks you questions on services that aren't Microsoft owned. It's that broad. So yeah, that exam is difficult. But AZ220, I don't know. I'm part of it, so I'm always pushing to make sure that if you're doing the job or you've done your research and you've done your learning, then you should be able to pass it. There shouldn't be trick questions in there. Is the point?
Yes. Yes, I think that brings the conclusion here to the questions.
Cool. Good. Well, yeah, thank you very much for having me, and thanks
thank
everybody
you so much.
for coming along and watching.
Thank you a lot for your session.
Yeah,
And
no worries.
Peter, please stay a little bit here on the line while we are finishing off the stream here.
Of course, more than happy to. Thanks again.
So yes, so we have just a little bit information here from us. So first thing is, if you're interested in speaking here at our show, you can always submit to our sessionized call for papers or call for speakers. So you can see that on our slide over here. And we can also say something about our next session. So our next sessions in 2 weeks will be on cognitive services, and it will be Priyanka Shah who will take that session here for us. So anything else, Eve?
I don't have much more, but maybe we can tell a little bit of our plans as well. Because as we did last year as well, in the end of this part of the year, let's say like that, so before we go away for summer vacation, we would like to bring back all the speakers we had since January and talk with them about very important topic in the field, which we are going to tell you probably at the next session. So you should stay tuned.
Yes. So have a happy May 4th. And
May the 4th be with you.